Hello, welcome back to Learning Image Analysis. In this lesson, we'll be building our first algorithm to analyze a fairly simple image. That image is displayed here. It's a scanning electron microscope image of some gold nanorods. So once we've found all these nanorods on the screen, we're going to count them and we'll measure the size and shape of them all. So some objectives for the lesson, things that we'll learn as we build our recipe. First is just basic thresholding, how to differentiate your features from the background based on grayscale intensity. After we try this basic thresholding, we'll recognize when noise reduction would be helpful. And then we'll do just some very simple segmentation cleanup and then perform some measurements at the end. So let's move over to MIPAR. Here we have our image loaded up in MIPAR. And when we first look at this image, we see that our nanorods are darker than the background. And also that the grayscale intensity of the background doesn't change across the image. The whole image is fairly uniform. So that tells us that we can probably use a basic threshold to segment it. So what the basic threshold does, if we have MIPAR automatically decide our value for us, is it picks a value, and then anything on one side of that value is selected, and anything on the other side is not. So here we have all the dark selected, and we can see that it does an okay job here. Some of these darker features, it looks alright, maybe a little bit beyond the edge, but some of these lighter features aren't getting selected well enough. And also you notice that this boundary is really rough. So what can we do? Well, we can try to adjust this boundary so that it's okay. Clean this up a little bit. But if we go too far, we notice we start to over-select. Here we're starting to select stuff in the middle. Okay. So what to do? What do you do when your segmentation isn't really cooperating nicely? Well, you can clean the segmentation, which we will do in a minute. Or another option is to actually clean this grayscale image first and do some noise reduction on it and get your segmentation to be better off the bat. So let's do that. Let's pull out one of our noise reduction filters. We use the non-local means. So if we apply this non-local means here, voila! All the noise is gone. So non-local means is a very powerful filter. If you haven't used it before, it'll change your life. So now we have our noise reduced image, and let's see what it looks like with our basic threshold again. Right? It's a lot better. We can see that we have a clean boundary on this lighter feature without terribly over selecting this darker one. It's not perfect. You're never going to get a perfect segmentation, but it's very close. And if you keep your value the same between your experimental images and your control images, then it will be good enough. So here we have our selected images, our selected nanorods, but there's still a few adjustments that need to be made. First, we'll notice that there's this bright spot of noise right here in the middle that needs to be eliminated, and we've got dark text on the scale bar that needs to be eliminated as well. So the first thing we'll do is use our morphological operations to clean this up and we'll use our dilation and our erosion. I use these on almost every single algorithm that I build. So the first thing we'll try is eroding this algorithm away, eroding this selection away. So if we shrink everything that we have by a single pixel, it's enough to get rid of this. Now, of course, we need to grow it again in order to bring our original segmentation back to its original spot. Okay. So that gets rid of noise that you didn't want here. And then, to fill in holes, we'll do the opposite. We'll first dilate, and then erode. Just like that. And now we have a cleaner image. The second error in our segmentation that we need to fix is the fact that some of these features are joined together when they shouldn't. Some of that is due to the initial segmentation. Some of that is due to our morphological closing operation here. But either way, these can be separated with our separate features function. In other words, this is called a watershed function, and we'll talk about this more when we get to the segmentation manipulation section later in the course. But for now, just know that it separates features that are joined together. Just like that. Alright, so let's make sure everything is separated properly if we randomly color our different nanorods. And it looks pretty good. Everything looks separate, except for this one down here. That one got cut when it shouldn't have. But when we're looking for size information, when we're looking for shape information, we obviously don't want to count features that touch the edge, because the whole feature isn't in the image. So the fact that we have this mistake caused by the separate features doesn't bother us, because we're just going to remove all the edge features anyway. We also notice that this didn't quite get cut here, so we can increase the strength of the separation a little bit. Okay. Now let's remove those edge features as we talked about. And here we have our complete nanorods. So I'll give these guys a name. Nanorods. And now we can proceed with the measurements. So we'll measure shape, we'll measure the caliper diameter. This is the largest diameter across the feature. We'll also measure its area, and we'll get an eccentricity measurement as well. And see what we end up with. So here we have our features colored by area. Obviously the bigger ones have bigger area. And here's our really large feature right over here. We have their eccentricity. Here's where we can clearly distinguish the ones that are rods and the ones that are squares and circles. So if you wanted to just look at the rods, we could use this eccentricity measurement as a discriminator. So let's try that just for sake of argument. Say we have a cutoff here of eccentricity of about 0.7. Okay. So after we remove edge features, let's reject features based on eccentricity, and we want to remove everything below 0.7 form. So here we have all nanorods. And here we have non-circular nanorods. Okay, and now we can measure, say, just the non-circular ones and see what they look like. Okay, and of course we have a compressed area histogram as well, because this one giant feature isn't present. Right, so that's all I had for this particular lesson. It's a very simple recipe: noise reduce, perform a basic threshold, do some simple morphological operations, here an opening and a closing, to clean the segmentation up a little bit, separate features, remove edge features, and then divide the nanorods up into classes. Right, so I'll leave it at that, and we'll see you next time when we'll delve into a different image. Our next lesson will be cleaning a messy segmentation. We'll have an image that will require a lot more work, a lot more massaging in order to get a proper, nice, accurate segmentation. So we'll see you next time.